am Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions in the Department of Civil Engineering in Foundation Engineering subject in Unit 2 Slope Stability. Now let us consider another example 2 wherein using the Fellenius method of slices. Determine the factor of safety in terms of effective stress of the slope shown in the figure. For the given failure surface using peak strength parameters, C dash is equal to 10 kilopascal and phi dash is equal to 29 degrees. So the unit weight of the soil above and the below of the water is given as 20 kilonewton per meter cube. So in this method, Fellenius method of slices, factor of safety need to be determined in terms of effective stress. So the cross section is given here, and if it is noted that the potential given surface is shown here, and these are the normal forces which are actually passing through that, and these are the tangential forces as already we have discussed in the different method of slices, wherever the normal forces and tangential forces are acting perpendicular to each other, and these are the weights, this force triangle, and these are the normal reactions. These are the shear forces which are acting mobilized by the soil, and the weight of the slice and the slope inclination is here we have shown slope inclination 1 vertical is to 1.5 horizontal. So that we are interested in that what is the factor of safety of a slope for a given slope inclination. Generally factor of safety is equal to 1 means we say that it is the at the wedge of failure, and the factor of safety is equal to 1.5 for some slope. If it is designed, then it is said as a stable slope, and here the r is equal to 9.5 meters and vertical distance is about 9.15 meter. Here one approximation in Fellenius method is that we calculate the mu pore water pressure value with reference to this vertical height, but in reality when the water table is actually varying inclined like this shown in the figure, one need to consider the particular height. That means if you consider this reduced distance, then z effective is this height. So but in this Fellenius method we estimate the factor of safety at this the center of the slice. Wherever the water table surface is here, we take the entire area. In this particular height we calculate what is the pore water pressure and multiplied by this length, we will get the mu into L. But in reality it is this particular height determined with this Z into W. We end up in the conservative slice, so it is actually safe for the slope which is being designed. So this is need to be understand while using the Fellenius method or Swedish method of slices. So the computation works out wherein we divided it into 8 number of slices as we have seen in the figure, and we determined rate of slices and which are obtained as it can be shown in terms of h cos alpha or h sin alpha. We can actually adopt simplified procedures like slice number and weight computation and alpha, that is obtained graphically, then calculating w cos alpha, w sin alpha, and also by noting down, let us say h is the height of slice in the center, but if you consider, let us say that 3/4 of the height is say up to water table is there, and that z into w into gamma you will get the pore water pressure, and then graphically if you measure what is the length mu into L, pore water pressure, pore water force we can say per meter length. So by using this expression factor of safety in terms of effective stress, we can calculate C dash LA plus tan phi dash into sigma W cos alpha minus mu L by W sin alpha. So the computation after simplification you get the factor of safety as 1.42. So it indicates that the slope which is 1 vertical and 1.5 horizontal is having the factor of safety of 1.42. If one needs the factor of safety more than 1.3, and that it indicates that the slope needs to be flattened. It means one has to go for one vertical and two horizontal from constructability point of view. Then the slope is said to be ensure the higher value of factor of safety.